So welcome everyone to our first edition of Drones in Other Fields. Tonight we decided to engage this talk in the medical field. And so we have our three panelists tonight. Dr. Valerie Homier, which is a specialist in emergency medicine at MUHC. We have Martin Leprohon, which is a designer and an aviation expert at Airbiz. And finally, we have Reece, who is the CEO of InDro Robotics. And I'll be passing on the torch to Valerie so that she can start and tell us a bit more about herself.
Hey, everyone. Thanks for joining. Thanks for your interest. The reason I said yes and I agreed to participate is because I think this is a great group of young people. This is our future in development. I believe that taking the time to discuss with you, to share our experiences, and maybe let you meet some fantastic colleagues of mine, I thought there was no way we shouldn't make it work. So it's a pleasure and honor for me to be here with you. I work full-time at the McGill University Health Center, at the Montreal General Emergency Department, and also at the Royal Victoria Hospital. So two different patient populations. One is the trauma center. The other one is a cardiac and transplant center. In addition to that, I'm responsible for disaster preparedness for the McGill University Health Center. And yes, we can see on screen some pictures. That's nice. In 2019, we conducted this study. It was a big team. The first slide, you saw the first picture was the entire team. So I don't know if you want me, I didn't think it was necessary to take a long time to introduce myself. Is that enough, or you'd like to know more?
I mean, that's up to you. I personally would like to know more, so probably everyone as well.
Okay, so you know about my full-time commitment, so clinical with patients and non-clinical, managing disaster preparedness for the MUHC, but I also do research. This is off hours. So Philip and Martin know that sometimes I send emails late at night. It's just because that's when I can sometimes find some free time to do the other projects. And also because I do shift work, right? I work day, evening, night. It's a bit random. So that's a bit of a different lifestyle that I have, I guess, compared to the population in general. But you can see here pictures. Yes. So this was from the 2019 research project we did together. We did one also the summer before at the Mont-Tremblant Ironman, which I don't know if the paper was shared with you or what, but it was published in Pre-Hospital and Emergency Care. And just like we were chatting with the organizing committee, it had to do with surveillance of swimmers during a competitive event. And I was just mentioning that Martin, which you'll meet very soon, and we met. We were friends and still are to this day. When I was 16 years old, we were on the same lifeguard competition team. And so it's interesting to see that several years later, this passion evolved into now using new technologies to maybe do the job better. So it's just interesting. Whatever you do young, it always has an impact on future projects you get involved with. So I did a European Master of Disaster Medicine, which I completed in 2018. This was out of Italy. And so that was another great experience. And right now I'm just continuing to advance knowledge. How can we respond to disasters better? The COVID pandemic is one kind of disaster. There are many kinds. It'd be a pleasure to discuss that further, but I think it's time to let my colleagues also introduce themselves, because I'm not an engineer and they both are. So let's hear their bios.
All right. So Philip, would you like to go ahead?
Certainly. So my name is Philip Reece. I'm the CEO of InDro Robotics. I was the one on the left standing next to Valerie there. There we go, the taller of the two. I've been working with drones since I sold my airline. I owned an airline before I did the drone company. So for the last 7 or 8 years, I've been at the cutting edge of drone technology here in Canada and a little bit in the US and Europe. We build drones as an OEM, original engineer, manufacturer, as well as integration of other people's equipment. The reason I said yes to this meeting was because Valerie told me to, and I've learned from my previous experience that it's usually easier just to say yes to Valerie, which is why we ended up in the middle of a lake filming swimmers with the drone, which was actually a really great experience. We ended up trying to be able to detect, it was the project Valerie mentioned there, using the camera on the drone to feed into an AI to see whether we could tell the difference between a swimmer who was doing well and a swimmer who was in distress. It led us into quite a lot of other really cool AI projects, including counting penguins and counting narwhals, not at the same time. And we've continued to develop on that. We've also done lots of development with Transport Canada, who's the regulator for the drone industry here in Canada, obviously. And we were the first to fly beyond visual line of sight, the first to fly long distance over cellular. We've had lots of firsts. We're also the first in Canada to have a CTA license, which is relevant in this case, because the CTA license is the Canadian Transport Agency license, which allows you to carry cargo. All aircraft, commercial aircraft carriers have this CTA license, but we're the first and only drone company to be allowed to carry cargo. So when we're looking at things like this, which is what we're going to talk about now on the blood delivery side, that would be classed as a cargo where you need a CTA license. And I think we're going to touch upon a number of things, not only the technical and regulation, not only the technical challenges, but also the regulation challenges that stand ahead. We did have a run through of a few things we wanted to talk about, so I won't dig into those too much, but that's basically our bio, my bio rather. InDro Robotics has grown now to a team of 26 people. We've got offices in Ottawa, offices in Vancouver, and offices in Victoria, but we tend to base ourselves as well out of our clients' offices. So we work with the paramedics out of Renfrew County, where we're permanently based as well. So over to you, Martin, and I'm sure we'll catch up on some more questions later on.
Thank you very much, Philip. Hi, everyone. My name is Martin Leprohon. I'm an airport planner for a company called Airbiz Aviation Strategies. We're an aviation consultancy, so we primarily work with airports and sometimes airlines in designing and planning their facilities for the short, medium, and long term. I graduated from University de Sherbrooke back in the late 90s in mechanical engineering. And when I finished university, I still had no clue what I wanted to do, to be honest. So I had just finished an internship with Pratt & Whitney Canada in Longueuil. So that's what triggered my interest for aviation back then. But I went and, like Valerie said, I traveled a bit and did some surf lifesaving competitions and went to Australia, where I went on and decided to do a degree in a fairly general degree, but in aviation. Just to get to learn all the different aspects of operations and technical aspects around the airports back in Australia. And I got lucky enough to find work whilst I was there. So I've been with Airbiz for the last 15 years. They've been, so I started with them back in Australia, and I've been in Montreal for the last 10 years, roughly. So the interest for the project, I guess, as Valerie said, we had a common, we had known each other for a long time, and she knew I was in aviation and told me about this project she had done the year before at the Ironman in Tremblant, and mentioned this new projects about the drone delivery. Sorry, blood delivery by drone. And I was quite intrigued because at the time I was doing a bit of a research and development within my company about the growth of drone deliveries in the aviation sector, but also urban air mobility. So air taxis and the growth of Uber Air, for example, was being talked quite a lot back in 2019. And roughly at the time that this project was kicking off, our head office, which is in Melbourne, got named as a first trial site for the new Uber Air product. So that was part of the interest for that project. So my contribution for the project was fairly limited, but it was really focused on the elements of where the market is going, so that we can allow airports to better plan for these types of future operations. And I'm sure we'll speak about that extensively today. But I think that what's great with this project is that it's an enabler for a lot of other applications, but it's a great case study because it's something that has community buy-in, as opposed to other things like that we can discuss later with deliveries of coffees and burritos. So, so I'm sure we'll talk a bit more about that. That's it. Thank you very much.
All right, perfect. So let us start the event. We prepared a couple of questions and we'll be asking them to our panelists, and they will be answering together, I suppose. So for our first question, how would you define a medical drone or a medical drone operation? And so what really makes a drone a medical drone?
Should I take that one? So
Yes.
a medical drone, as I'm sure we've all seen here, there's all sorts of drones, and majority of them are sort of in the small UAV category, which is in between 250 grams and 25 kilograms. It's important to make those two sort of bookmarks there, because less than 250 grams isn't covered by Transport Canada regulations, and over 25 kilograms requires a special flight operation certificate. So in that gap in the middle between 250 grams and 25 kilograms, we can do an awful lot. And that's really where we specialized here for the medical drone. The drone needs to be capable enough to fly long range. And by long range, we're really talking about sort of 20 to 30 kilometers. It needs to make it from a hospital to a hospital, or blood bank in this case to a hospital. And most of those can be done in sort of that 25 kilometer type range. So it needs to be big enough to fly that, powerful enough to fly that. It probably needs to be a rotor, multi-rotor, rather than a fixed wing, because it needs to land and take off in fairly small locations. So it needs to be the helicopter type build rather than the fixed wing aircraft type build. It needs to be able to carry cargo, obviously, because it's going to be carrying these items, probably in a slung load underneath. So the drone needs to be able to stand reasonably high, carry a cargo load that can either be detached or lowered, which a lot of companies are experimenting with. It needs to have an ease of being able to load that cargo and detach that cargo when it gets to where it needs to be. So that's on the physical side. Basically, we've just built a drone, which is probably 25 kilograms. It stands at least 1 meter tall. It's got a cargo bay underneath. It's probably got 6 rotors at least, so you've got some redundancy in there. So physically, that's really what a medical drone would look like. On the operations side, however, it needs to be super simple. So it's going to probably be operated in a reasonably high stress environment. It's going to probably be operated not by engineers or drone specialists, but by pilots or industry users. So it needs to be as smart as it can be all on its own, and it needs to fly from A to B as quickly as possible without somebody doing a whole load of programming to it. To do that, it needs to be a well-established route. It needs to be approved by Transport Canada to fly in probably complex airspace, because lots of hospitals have helicopter helipads, which would be classed as complex airspace. And as it's flying that 25 kilometers that we talked about, it could well go through complex airspace. So it needs to be a really well tried and tested drone with some what they call DAA, detect and avoid systems on there, so that as it's integrating with other aircraft, it doesn't get in the way. It manages to stay out of the way. They'd be the real fundamentals, physical and software side, and then regulations, which we'll talk about a little later, I'm sure.
Thank you very much, Philip. Martin, Valerie, do you guys want to add something to what Philip just said, or shall we move on to the next one?
No, and I think that's one thing you'll note from today's conversation is that a lot of, regardless of whether it's a medical drone or a regular drone, it's the same rules we've got the same obstacles, regardless of the type of use.
All right.
I have a question. Will there be a question period at the end, or
yes,
can we ask questions as we go?
We'll be answering questions from about 7 till 7:30. So write them down. And you can also actually ask them in the chat. We have 2 representatives who can assist you with that as well, if it can't wait. All right. So the second question. In what scenarios is a medical drone more useful than a standard form of transportation? For example, I know that in Rwanda, drones are currently being used to transport blood because the roads are very unstable for ambulances. So which scenarios would those drones be more useful than the standard forms?
I'll start off because we're already doing quite a few drone delivery type programs. We're actually on the West Coast here, we're delivering to remote islands. So we're delivering to Penellicut Island, Thetis Island, Salt Spring Island, all from Vancouver Island. And the main reason that it's useful there is transportation to those locations, even though they're quite close, is difficult. We're reducing a 4-hour ferry trip to a 7-minute flight. So you can imagine putting a nurse back in a community rather than having them carry a sample on the ferry if they can just fly the drone in 7 minutes. So it's speed is obviously a main scenario because critical infrastructure is already broken, as you mentioned, in Africa, or through a snowstorm or landslide or ice bridge. So it's really about those physical barriers. I think that's when you would use a drone, or for immediate urgent response. Nothing moves quite as fast as a drone unless you get into a helicopter, and often a helicopter will need quite a bit of prep time for it to be able to go. So it's speed of response, restrictions of alternative ground transport. And then the last one that we're really finding more use now than we ever expected to is short route repeatability. So if we're flying from on campus, for example, at UBC, we're flying from one side of UBC to the other side of UBC. It's quite easy to get on your bike or in your car or even walk it, but the route is only taking 3 minutes, and it's amazing how much people will start to use that. You put the cargo in, press the button, it's there in 3 minutes. It's like, you know, the old chutes they used to have in banks where you put it in and compressed air to the other side. People are no longer thinking about it as a drone. They want it there, so that's what they do. They give it to the drone.
Valerie, Martin, any additions to what Philip just said?
Yeah, again, for me, I have an interest in disaster preparedness, and that's how the idea for this study came, was to think, what are we going to do if we need blood products, massive amount of blood products, in a short time when all the highways around Montreal are collapsed due to either a major collision, an ice storm, snowstorm. You know, these things happen. Eh? Maybe some of you were stuck a few years ago when for 12 hours, people were immobilized on the highway because of a major pileup, car pileup. So these things happen in Montreal, and history tends to repeat itself. So that was the idea, essentially, that to be able to have a plan B if you cannot use the regular transportation vehicles. And so also for safety of first responders, I think that's, we haven't mentioned that, but there are some sites, disaster sites, where it's unclear if it would be safe. And right now the first responders are trained to wear some protective equipment and go and try to identify the toxic agent or the actual situation. Well, drones could certainly help with recognition in these circumstances. Anyway, there's many applications. I don't know if we're getting into a different question. Well,
we'll jump on the next question, and okay. I think it will probably what you just started.
Yeah.
So for the next questions, what adaptations have to be made to fit the specific product being delivered? So how can we really modularize a drone for different purposes? We know that, you know, drones can come in different shapes and different sizes. So are they really modulable so that we can adapt them to different situations?
We're certainly building them in a modular type of environment. So basically, we start to think about the drone just as a platform in the same way you would a helicopter. And it's all about the payload that you attach to it. Having the drone have the hot shoe ability so that the payload that's attached has power going to it, so that we can interact with the with the payload. Maybe it's got a temperature sensor or a vibration sensor, so it's giving input to the drone to make adjustments, or whether it's the other way around and the drone is connecting to the payload to make it do something, whether it's lower into the area or detach, or in one instance that we're working on now, we're working on a payload that's actually got 3 payloads, and it can drop 1 at any one time, and then the other 2 actually have to move to accommodate the weight and balance of the drone so it doesn't throw it off. So the drone really just becomes a platform, and then it's the payload that becomes modular. So connecting it on and then making it work is the cool bits that we see as being modular and different.
Martin, would you like to add something to this?
No, not to this question.
All right, Philip, I think I caught you. You were going to add something.
I was going to say probably to Martin's comment that he made earlier about drones, whether they be medical drones or commercial or even hobby drones, get caught in quite a lot of the same regulations and use and rules. This is where we make a difference there, because the drone would likely be fairly different for this type of use, because it would be bigger and heavier and have those abilities to swap payloads. So whilst it'd be covered by the same rules, it would be a different type of drone.
All right, perfect. So let us move on to the next question. What is the biggest obstacle, in your opinions, in developing a medical drone specifically? So we have the technology, but what really stops the hospitals from using it? It's actually a 2-part question. I believe the second part would go to Valerie, since it's more medical. But the first one could go to either Martin or Philip.
Go for it, Martin.
Well, I guess the first thing, and that's when you're dealing with aviation and you've got an emergency. Let's just think about medevac of passengers that are in remote location. You just simply apply the existing rules and framework to carry passengers from one airport to another, and you then bring them onwards to the hospital. I guess the problem with drone operations right now is that there's not necessarily this ability to just readily initiate a transport without planning ahead of time. So this research, I guess, was part of that progressive buildup of the framework that will allow these operations to take place more seamlessly in the future. Maybe going back also to Philip's point earlier about predetermined shipment between location. If you've got these pre-built corridors, then it allows to more seamlessly and effectively initiate these transport. But at this stage, that's still something that's being built up progressively.
So what really stops the hospitals from using it, Valerie?
Yeah, that's a good question. Well, I wouldn't say stop. Like, I think in general, the medical field has some innovators within the field, but the actual healthcare system is a slow moving entity. So you may have great ideas as someone who's involved in healthcare, but it's hard to have the system work together and change the way they do things. The system does not change quickly. Like, I'm just giving an example, like we had to go through electronic charting. This was a change that occurred about 10 years ago. So right now when I go to work, I do not need a pen. But we're one of the few hospitals who work like this in this province, not in the world, but in this province. And why is it so slow? Why, if one institution can do it, why can't they do elsewhere? It's because it's complex. And the funding also is an issue. There's not that much funding for change to occur quickly. You will find funding. It will take time. It's just not quickly that people start seeing a reason or an importance in funding more studies on this topic. But once you get the ball rolling, then and you convince people of the advantages, then certainly it will be possible. There are centers now who deliver their organs for transplantation through drones. Okay, that's being done. So we're not the only center who is trying to see how things can be done differently. But if I really summarize the answer to the question, why are hospitals not all doing this right now? Well, number one, not everybody, if you ask my colleagues, they don't know much about drones, to be honest, okay? It's not something they teach you in medical school, okay? So that's first. Number two, the system, the organization, healthcare in general moves slowly, change slowly. Number three, funding. And I would say number four is safety, right? That's also one reason the medical profession doesn't change right away how they treat disease, or they wait for confirmation, good studies. They're careful, they're cautious. And the same way you wouldn't want to start a technology that hasn't been really demonstrated to be, first of all, beneficial, and in addition, safe. So we need more studies. That's my message before doctors and nurses and our governmental healthcare leaders will want to invest into changing technology. So I don't know if it answers, but it was kind of an overview.
I think it does. Yeah, definitely. I think also, well, I'm going to give quickly my a very small thought I had. In the medical field, usually they wait for a very big event to happen so that change happens. But when it happens very quickly. But for like 10 years or so, it's more or less slow. For example, the pandemic this year accelerated the vaccine industry a lot. We saw a lot of new technologies. All right, so Martin, Philip, would you like to add anything else, or shall we move on to my question?
Well, maybe quickly, it's the aviation sector is also a very risk-adverse industry. You saw it with the Boeing 737 MAX, the very highly publicized 777 losing an engine. So it's not the kind of things you like to see happen, but in a way, a lot of the risk safety layers played a role that prevented a bigger catastrophe. But you don't necessarily want to move from one way of doing things to another, and without knowing all the new risks that you're introducing. And I think that's the same thing for the healthcare sector, but aviation does look at things very carefully before making the implementation of rules that will enable these types of transport for the longer term.
Mm-hmm.
Perfect. All right. So what specific risks have to be considered with respect to drone malfunction during a delivery? We can see that into two perspectives, the drone side and then the medical one. Philip, would you like to start?
Certainly, yes. On the drone side, I mean, we really have to watch against a flyaway, as we call it in the industry, which is basically where you send the drone from A to B and it ends up going off all on its own to somewhere else. It's happening less and less as the technology becomes more developed. And the big risk there is it's going to fly into general aviation. It's going to fly up where there's aeroplanes and helicopters and cause a potential accident or incident. There's plenty of mitigations around that. We now have multiple means of communication to the drone. We fly over RF, we fly over cellular, we fly over satellite. And at any point along that mission, we can give it a come home command. If for some reason it's got a dual malfunction, it can't come home either, we can also issue it with a kill command. A kill, unfortunately, means the drone's going to come down, which obviously is a concern, but we can then blow a parachute. So we can put a parachute on there. So whilst the drone may still land in somebody's back garden, it'll land slowly, hopefully. So a flyaway is a risk. A CFIT, as we call it in the industry, which is controlled flight into terrain, which is basically where you tell the drone to go from A to B, but maybe as you're flying in bad weather, or maybe you pilot error, you put in the wrong route, and you crash. In this case, it would be into a building most likely. Those risks would be mitigated quite a lot by having experienced personnel, but also by having pre-surveyed areas and pre-surveyed routes that the drone was flying in, so that you would have plenty of warning. Also by having detect and avoid systems on the drone, so that it doesn't allow you to crash into things. These drones are getting that smart, so they don't really just crash into things anymore. You could, of course, have a catastrophic error where just, the drone, like the aircraft that lost its engine, a drone could lose its engines as well. These things do happen and have to be accounted for. In that instance, we are trying to mitigate them by putting more engines on the drone so that it can at least return back to base or have a controlled flight to the ground. But the big risk is invasion of airspace that's used by other users and not giving way to them, causing an aircraft incident. Crashing to the ground, the chances are, whilst it would be obviously a big bag of blood getting dropped onto the ground from a drone would look pretty horrific, chances of an injury are fairly small. So yeah, they're the real risks of a drone malfunction on a technical side of things.
All right, yes. It will look like a crime scene if there's
Yeah.
a bag of blood in the drone.
And I would just add also the human drone interaction. Like, say we are passionate about drones, we do more and more research, and we can demonstrate that it's faster, it's more efficient, more reliable. Okay, great. But now all the other people that will have to use the technology and they haven't spent all this time dealing with drones, they may have fears and they may not know how to behave beside a drone. There might be safety issues with the interface with the user, the one receiving whatever the drone is transporting. So we need more study on that part, but that transfer needs to be safe as well.
Yeah, definitely agreed. Well, the next question can kind of touch upon this, and I'll direct it to Martin specifically. How do these drones navigate airspace laws and restrictions in urban areas?
So I think we've raised a few of these elements to date, but maybe to give you a bit more practical example for this study. I mean, ideally, what would have been great is flying the blood directly from EMA Quebec all the way to the General Hospital. But it turns out that the blood bank is literally under a flight path to Montreal Dorval, which introduces a pretty big risk, and it's very close to the airport. And it's interesting because a few years ago we would hear airports complaining that there's issues with drones. You might have heard about Gatwick, where the airport had to be closed for a few days because there were a drone that they couldn't identify who was flying it. So you've got this situation where airports initially pushed back and didn't want to see any drones in the vicinity. Some airports got warmed to the idea of potentially using drones for their own operations and own maintenance and operations. And now we're actually getting contacted by airports who want to make sure that they're able to plan their facilities and the land around the airport to facilitate drones coming in and out. Obviously, not of the runway, you want to keep them away, but try to bring them as close as possible to businesses that might have a business in the drone delivery business, like with the likes of Amazon and everything. So, I mean, we're seeing that the industry is very conservative when it comes to regulation. It wants to make sure that it doesn't open up the field too quickly, so it's very restrictive. But progressively, as you build the cases and you build the risk mitigation measures and the tools, you can actually come up with a concept of operation that is safe and effective.
Philip, Valerie, would you like to add anything to that?
I think Martin really pinned it down there, and Transport Canada, being the regulator and being very safety conscious as they are doing these things in a very stepped approach. They've allowed us and 2 other operators in Canada to sort of go beyond the rules in a very controlled way, so that we can now give them feedback. We're flying beyond visual line of sight, which is further away than the operator can see the drone. And the agreement that we have with Transport Canada is they give us these permissions, but we have to give them feedback, good and bad, on what went wrong and what didn't, so they can adjust and tweak these rules. And it's slow, I mean, aviation is a slow industry. It's been built on tens of years, well, over 100 years now of aviation experience, I guess. So it really does allow us to do that crawl, walk, run approach. And I think the medical drone is a perfect example of that, because there's a real use case there. It isn't doing the delivery of shoes. It's something vital. It's something important. It'll be one of the first use cases that get released. Yeah,
so just to come back to the project, when we were trying to figure out the route, as Martin said, we couldn't fly direct from the Quebec distribution center all the way to the general, which is what we wanted. But they gave us two options. You fly over the Mount Royal or you fly over the St. Lawrence River. That was it. We were not allowed to fly really in the middle of town. I'm wondering if they would be more open now. There's nobody downtown. Maybe they would. I'm joking. But back then was very crowded, obviously. But we did it. I mean, it's feasible with a good team that has a good track record and under very tight professional approach. We had some weather issues during the data collection. I don't know if we're going to discuss that, but I remember very well how Philip managed this. He had to make the call, are we flying or not? And at one point he said, no, we're not. And we had to delay data collection. But that's an example of a safe procedure. You do want to complete the data collection, but you're not going to do it at all costs. You have to be safe. And it's only with this kind of attitude that you can go on to the next project and continue developing. If you're reckless, they won't let you do it again.
Yeah, it takes a lot of time, I suppose. All right, so we can move on to the next question. Do you see drones complementing or substituting helicopter operations in hospitals? Like we know helicopters have been used a lot, specifically to transport people the fastest way possible. Would you think drones will at some point replace this this way of transporting patients?
Well, for that's a very good question. Because we've been speaking primarily about delivery drones to date, but there's the concept includes as well more and more the concept of passenger drone, and what we've been seeing is that the rules are primarily based on existing helicopter operations, but obviously the ultimate goal of this business would be to allow these types of vehicles to operate autonomously without any pilots at some point. Maybe one topic to bring in the mix is the fact that right now you've got airspace management is by air traffic control, whether it's at the airport in a control tower or in a regional center, and basically segregating traffic. If you're going to start having drones flying all around and potentially passenger drones as well, there's going to be a point where that traffic needs to be segregated. So you've got the concept of unmanned traffic management, and there are tools being built. It's a stream of research that's taking place right now to try to not increase the workload of air traffic control and keep segregated the two types of traffic. There's that vision that maybe over time this could all be merged together, like when you're watching the movie Fifth Element or Star Wars, where you see all the vehicles flying around and commingling together, maybe at some point in the future. But for the time being, the two airspace are segregated. Now, for the helicopter transport, I mean, one of the reasons that passenger drones are getting traction is that the ultimate objective is that they would be cheaper, they would be electric, and they would be therefore green, I guess, and that's part of the appeal for it. Well, the jury is still out on whether or not that can be deployed at a large scale, but for, again, specific applications such as relocating patients or transporting patients in an emergency, that could be a really good case study to progressively build community buy-in for that type of service.
Yeah. A follow-up question, actually, that I just came up with. I know that Amazon and Walmart are funding a lot of money on those drones. Do you think they will benefit as well the medical industry, or not?
Any group that's doing research in this space really has to end up with the regulator to get those permissions. And the regulator, once it's with the regulator, it's a universal permission, so we'll all benefit from it. So research across the board, as long as they share it, which they'll have to get permissions, will benefit the industry as a whole. Yeah.
All right, Valerie.
Yeah, I think time will tell. I think that we need many more years to see a complete change the way you were describing, to like replace the helicopters by drones. I think that's a long time from now. But I think what we probably will end up seeing is more and more partnerships. I don't think that the medical field, at least not the public healthcare system, can do this alone. We need collaboration. We need partnerships for research, for funding as well. So I think unless the private healthcare system takes this on, that's something I would be sad if it was only that and no role for the public healthcare system, but that's a possibility as well. My favorite approach would be partnerships, collaboration. I think that's the way to go. Fields have been traditionally working in silos, and I think we're having this great multidisciplinary session. It's not something I've been asked to do very often in my career, and I think that it just shows that maybe the newer generation is much more heading in that direction, and I think that's the way for the future. Collaboration between experts of different fields and find a way to create technology that will actually answer the needs of the healthcare. So I believe in this, yes.
All right, perfect. So a question for you, Valerie, actually. How likely is it for drones to be used for the delivery of something like vaccines?
Well, I think it was mentioned already, it's happening. There was some papers, a lot of people sent to me the information that Ghana has launched this world largest drone delivery system for vaccines. So it is already happening. And there's been many studies about transporting blood samples, lab samples, medicines. Philip will probably be able to add on that part. I know he's been involved in some of those projects. So absolutely, I think this will just see more and more. And I think what was not said, and I'd like to add here, is that not only deliver to hospitals, but I think potentially to vulnerable populations, those patients who do not have mobility. Now, if I can give concrete examples, so handicapped, paraplegic patients, those who have ALS, Lou Gehrig disease at home. We have senior citizens that live all in the same roof. Maybe, that would be useful for these kinds of patients. So, yeah, absolutely. Yes.
Philippe, would you like to compliment?
Certainly, yes. I think vaccines are being delivered, as Valerie mentioned, and we were actually involved in several COVID projects right now where we're delivering COVID samples, PPE, and just-in-time machine parts, ventilator parts as it happens. We haven't looked at doing vaccine. Well, we have looked at doing vaccines, but in Canada, I believe the infrastructure is probably going to be well enough set up by the time we got to a solution that would work. Hopefully we'll have rolled it out in traditional ways and we'll have it everywhere already. I think it'll be those areas that are special circumstances, as Valerie mentioned, people who are stuck at home, or maybe rural locations where they're closed for a different reason. For example, we're servicing a number of First Nations communities right now where they've actually closed off their roads. They've decided to self-isolate there, and they're not bringing the possibility into their community. So to deliver these via a drone brings almost a touchless service to them. So I think they would be another good use case. Hopefully we won't get another round of having to go through the whole vaccine situation, but in 12 months' time, I think we'll all be a little bit better equipped to deliver vaccines by drone.
Mm-hmm.
Well, that's good news. Martin, would you like to add something to that, or?
I'll add something completely unrelated with medical products, but I think it will probably come back to that in a couple of questions. Some of the trials around deliveries by drones at private homes, that's been done in a few places, including in Canberra in Australia, where I was saying earlier the joke about delivering burritos and coffee, but that was exactly what was being delivered. And it worked from a technical perspective, but there was a huge community backlash because it was done in a rural area or remote area where there's not high-rise buildings. It created new sources of concern by the population from both the privacy perspective and noise perspective. So there's lots of work that will be required on that front. And the problem with a lot of things like this is that it might be a medical drone, but your neighbor might not know what it is. And there might be some questions around the use and the reason why that type of delivery is being used. So the element of community buy-in and making sure that there's good communications and a good explanation of the purpose of these drone deliveries will be important in the future.
Yeah, so gaining the trust of the population, definitely. Well, I have another question. What does the process of leading a project like this look like? So it involves multiple industries, a lot of different people. So do you guys have any idea of what it would look like?
You want to know about project management for a project like the one we did together, correct?
Yes, exactly.
Yeah. It's complex, that's for sure. I believe engineers are trained for that. So this would be perfectly suited for one of you in the future to develop this. Maybe one day there will be a new specialty at McGill using, or maybe will be included in biomedical or some other part of your programs. But definitely project management was huge in this, this study. Multidisciplinary collaboration, can't do this alone. It's not because I have a good idea and I know a couple of people that necessarily it's going to go from start to finish. I need to be honest and say that there was a high chance of failure, and this was communicated to all team members. Everybody knew that if they were getting on board, we may never be allowed to fly because of the regulations, because of weather problems, because of our failure to develop an appropriate payload that was suitable. Or many different obstacles. Even the day before, we still were not sure, is there going to be a police officer telling us we can't fly randomly because they saw us on the roof because they're not aware. You still, the last minute, there was some uncertainty. So this was a project that required everyone to accept that risk and that possibility. Yeah, it was complex, but I have to say it was a fantastic team. And I think this is key. You need expertise to do something like that. You need commitment. You need a lot of, sorry, 1 second.
No, it's fine. Well, okay. So Martin, Philip, would you like to add something to that?
Yep, sure. I think what Valerie was probably going to say was how, or maybe she wasn't because she's too modest, was how we were all project managed quite well. So, you know, we did have these meetings running up to the event, and they got more and more frequent the closer we got to it. So we all knew what to expect. We all knew our expectations. We all knew what we were responsible for and how the next person's project, next person's input could impact ours. And we had a branch for, you know, how we were going to handle all of those. And then we had the real, you know, when we all arrive on site, we had a nice get together and a meal just to make sure that we all sort of knew each other and were comfortable, often disclosing information like, oh, the weather's not good enough, nobody's going to fly today, which is obviously disappointing news. But there was methods in place for we're going to fly tomorrow, we're going to fly the next day. And we had the planning in the morning and the hot wash in the afternoon to have a look at what went wrong and what we could do better. So it was a lot of planning, and it was a very active project all the way through. And it does need strong project management because you have got a lot of experts, and of course we all want to run the project. So you need a strong project manager to make it happen.
And just a couple of things, I'm sorry I got interrupted there. Just a couple of things I wanted to add because what Philip said is very, very good points. I'm just adding that I have to tell you, I spoke to everyone I could about this project. I didn't keep it to myself. I was out for dinner with some friends and I was talking, and then I met this person and met this other person. And like this, in the end, like there's many of these people that didn't end up helping out, but each one of these conversations led to something that eventually helped for the project. Like there's another group of people that are not here that helped provide us with communications during the project, because you need to communicate well between the drone experts, the pilots, those who are doing the actual data collection, the measurements, those who are monitoring the safety of the hospital, the drivers that are in their vehicles, because it's a race between the drone and the car, right? It was live. So we had to have really good communication and have redundancy. So basically clear task assignment, and definitely a lot of expertise. Different people had different roles. Nobody was doing the same thing as their colleague. And the last thing I would say is, yeah, you needed a bit of some crazy belief that this was maybe possible, that was really necessary, because Montreal had never done this. And so you have to think outside the box, find ways. Like if we can't fly from Quebec, then maybe we can fly from this roof of this building, which is an apartment building where maybe some of you live. We have to go knock on doors and just ask, would you let us fly from your roof? I mean, we have to do things like that, things I never was trained to do. So if you're going to do this kind of study, this kind of innovative project, you're going to go places you've never been, and you have to do things nobody taught you how to do. But you just have to be resourceful, believe, and communicate well with your team from the beginning until the end. Like data collection was organized. It was not chaos. It was decided in advance what we're doing. And so that's it. I could go on, but it was a very interesting experience, and I'm very thankful for the team. A lot of professionalism I saw in every team member. Yeah.
One of the students, Maya Darir, is asking if it was with the Renfrew paramedics, this project. Yeah, it was, right?
Absolutely. Yes.
Yes.
Would you like to tell us a bit more about this project? Oh, sorry, Philip, go ahead.
Sure. So Mike Nolan, who is the head of Renfrew Paramedics, we've worked together on a number of projects before. He was actually one of the first to be flying a drone beyond visual line of sight in Canada, mostly pushed on by the need. They did several ice rescues where they could send the drone out over the ice rather than putting paramedics out on the ice. So it was an easily identifiable need. And he's very forward-looking on the technology side, not just on drones. He was involved in Valerie's earlier project that we were talking about with Ironman as well, and then obviously came along on this one as well. Brings a whole wealth of medical knowledge to add to the team as well as sort of that emergency response. Everything Mike does tends to be focused on how can we keep not only come to the best outcome, but how can we keep the operators and the paramedics as safe and focused as possible so they can do their job. The other group that were involved were Exotactic. That's the company Valerie mentioned who were involved in communications. They're a local firm in Montreal. Great group with lots of excellent RPAS experience as well.
Martin, would you like to add something about this project?
Well, maybe quickly, because I don't think it's been mentioned, but what really impressed me about the research, well, the research in itself wasn't just about the timing of the blood delivery, but the work that Quebec did on tracking temperature to make sure. So the research was multiple-fold useful on different fronts. And also, not sure the exact timing, maybe Philip and Valerie can step in, but there was also this separate demonstration of the delivery of a defibrillator on Mount Royal that took place over the same couple of days. So it was a great use of time to demonstrate multiple applications with drone delivery.
Yeah, actually, that's an interesting point. And François Deschamplain was invited, but has a shift and couldn't be here. He's a colleague of mine at the MUHC. He's an emerged doc, but also engineer by training. He did engineering before. And so he's head of a foundation called La Fondation Jacques de Champlain. You must have seen it was in the news recently because they're trying to get people to sign this petition to have public access to AEDs across the province by legislation. That is, if you are a grocery store and you own an AED, you should make it public and available to 911 dispatch when someone calls for sudden cardiac arrest, for example. So anyway, with this organization, we partnered to apply to the city of Montreal to be allowed to fly drone over the Mount Royal. And it's only with such an organization that we were allowed to actually set foot on the Mount Royal and use the drone. You're not allowed. You can't just go over there and fly your drone. You need a permit, and you cannot get a permit easily. You cannot be a company asking for this. So the fact that it was a charitable organization made it possible. So this collaboration was essential. So I'm telling you, every person in the project brought something to the table. And also, we need to mention, I'm an emerge doc, and so is Francois. Initially, way before I saw an application for disaster preparedness, Francois and I, we were interested in drones because we're looking, how can we bring the defibrillator faster on a scene of a pre-hospital cardiac arrest. The problem we noticed through prior research, which I'm not going to discuss now, is that we get bystanders to show up on scene, but they often don't have the defibrillator. They forget to go and get it, or they don't know where it is, and it's just not well organized. So you need the defibrillator to shock within 4 minutes if you want to bring back with a neurologically intact human being. So I'm just saying, so all this prior discussion, research, and interest about out of hospital cardiac arrest led us to collaborate again on this project and make it possible that we can fly drones over the Mount Royal. We did not end up using that site for this study. We ended up flying from the roof of a building that we convinced them to let us fly from there. But our plan A was to fly from the Mount Royal Belvedere. Some of you might have walked up there. I mean, it's a common site we visit in Montreal. So that was one thought. So it could have ended up being our primary site for flying. Philip, why did we not do that in the end? There's too many trees, right? That's a reason. We visited this in the spring where there were no leaves. And then when it was summertime and I went back and shot some more videos and sent them to Philip, he said, no way, we can't do it. We can't see. So we had to find another spot for departure. So anyway, a complexity here, but that's what happened.
Exactly.
Okay, so it's 7 p.m. So we'll end this on the questions. If there is any other interesting point that you three want to talk about before we move on to the Q&A and that you didn't have the chance to talk about, please go ahead. Otherwise, we can move on to the Q&A.
Sure, I'm going to throw one in if you don't mind. Not really directly drone related, but we've also got another project on the go at the moment, which is ground robots in relation to drones. So we send a drone out to respond. In this instance, again, this is with Renfrew paramedics. We're looking for a missing subject, a missing person. We send the drone out, drone locates the person, pinpoints the GPS location of the person, and obviously responders head to that location. At the same time, we're dispatching a ground robot, which is on tracks. It's basically a mobile stretcher. Stretcher's folded in half when it's out in transportation. It's smart enough to avoid objects in its way. It's smart enough to put a follow me on so it follows the paramedic. And then when it gets there, the paramedic has all of the equipment at his disposal that this ground robot can carry. It can carry 150 kilograms of weight, so you can put quite a lot of equipment on there, basically bringing a lot of the facilities of the ambulance out into the field to be able to treat the person. You can then open up the stretcher and put the person on it, and the stretcher can go back to the ambulance, saving weight, obviously, and stress on the paramedics. So whilst it's not a direct drone project, it only really becomes useful if you already know where the person is, which is often identified by the drone. So there's lots of cool Internet of Things between drones, ground robots, and the people out there. So there really are some cool projects that students could get involved in. This one's actually based in Ottawa. So yeah, lots of cool other things happening.
Great. All right. So Valerie Martin.
So maybe before we take questions, sorry, I'm just going to say one small comment. I think that there's a lot of, I don't know, like 40 plus participants. And I think this would be a great opportunity to take this session, do some thinking, and see if this is something you could fit into your curriculum, and see if you can fit a drone project. get interested. I think one area that is easy to do is, and we need more studies, is the human-drone interaction. For us, when the drone landed on the roof of the hospital, only the drone pilots were allowed close to the drone. Okay, but in real life, if this was going to become operational, we would need a procedure that's safe, and a lot of different people will need to be able to interact safely with the drone, and we need to test that and see what kind of problems do we run into, and what kind of training can avoid them. So that would be good.
That's a great point. Martin, any last points you want to bring up?
No, good. Let's see where the questions leads us.
All right. So let us move on to the Q&A. Please unmute yourself and ask the question.
I guess I'll go first. Hi, I'm Martin. I work for innovation at Bell Helicopters, and recently they dropped the name helicopter from the Bell. So now it's Bell Flight, and they're very interested in developing drones in the 20, 70, 100, and 300 pounds gross weight payload. I have a question for Philip. You said the typical mission was said to be 30 kilometers without technical support at the other end. So basically, the real range that you require for the drones for a good medical application will be 60 kilometers plus safety. So the question is that true? And the other one is how much safety time are you using for those medical missions?
Good question, Martin. And we work with Bell Flight as well. And they've got two very interesting drone programs on the go at the moment. Heavy lift, I'm sure you're aware of. We've been both out to Mirabel and down to Texas to work with those guys. As for the question about distance, because we're looking at a medical delivery, we class this as a one-way. So we're either going from a hospital to a hospital, and the other side we can have the batteries recharged or swapped out and then send it back, or we're going from a center to an emergency response, in which case we also hope the paramedics are heading that way as well. So they would be responsible for picking up the drone at the other side when it arrives. Otherwise, we limit ourselves to 60 kilometers, which is too far. The technology just isn't really there to carry a usable payload 60 kilometers, 30 kilometers out and 30 kilometers back.
Okay, so you consider the people that are swapping the battery is not a technical support or anybody, it's just people that are trained to swap the battery.
Yeah, so we have pilot and crew. To pilot a drone on an advanced pilot's license, it's a minimum of 25 hours study time. That's just to get your license, and then we usually insist on 250 hours flight time on top of that, so that flight crew are fairly experienced. However, we've got down the basics of changing a battery. So sort of what Valerie was talking about. You know, when the drone lands, don't approach it, wait for the blades to stop. This is the button to pop to take the batteries out. This is the one to put them back in. And we've actually proved with the First Nation communities that we can train all of that over video. So we give them 4 one-hour video segments. And by the time they've watched that, we class them as crew, able to change batteries, approach the drone, reposition the drone if needed.
I don't know if that would work with a bunch of emerged docs. It's a joke.
Well, is it though? We work with firemen. Firemen tend to be the most destructive people of them all. So
not to touch it, right?
Yeah. So if it's fireproof, we think it'll be everybody else. One of the big problems we had on the human factors side, and I think this went exactly to your question, Valerie, that you encouraged the group here to look at, is if you're flying in with an AED, obviously the bystander has a real urgency to retrieve that AED, the defibrillator from the drone. And as soon as they see it coming down, even in our tests where we're doing timing against an ambulance, people get so enthralled in the action, they're starting to grab the AED before the drones even come down, which we can't do, or they pounce on it as soon as it's landed. So we started to put loudspeakers on there that says stand back from the drone and now clear to approach. But we don't know that kind of thing until we work with people who aren't drone experts. We tend to get a little bit stuck in our own research where we all know what you can and can't do. And we throw the public in there and it's completely different.
So that would be a question for Martin about the security. How do you certify the non-trained people receiving the merchandise at the other end? So any ducks or something similar?
Well, look, I don't know the details around that. What I've seen is and I was going to raise that point more in terms of industrial design and again the human-machine interface. If you look at some of the concepts that have been developed, like a lot of the flights take place and they land in an open site, and you just hope that there's a safe distance that's being kept between the drone and the person picking up parcels. But I think if we want something that's going to work on a large scale, you'll need something a bit more robust than that. And there's been some concepts where the drones can actually land on a pod, and the parcel loading and unloading takes place automatically. So the person who's actually on the ground
landing pad.
Well, it's if you look, there's what's the name of the company in Switzerland, Philip? I think is it Materna, or there's a company that built for Swiss Post. They built these pods where you just put your parcels inside, almost like a mailbox. I think it was a partnership with DHL, but and the box gets picked up, puts on the drone, and the drone takes off. One thing we've been seeing in recent years also is we're seeing there's a company in London London, UK, that's starting to investigate how rooftops could be retrofitted to allow a more convenient pickup and drop-offs of potentially passengers, but also parcels. So as much as what I said earlier about the delivery in rural areas where there's not noise, it's quiet, might be a bit of a challenge, and you're replacing basically a truck that just seamlessly comes into the streets, gives the parcel. In the bigger cities and where it's quite dense, the FedEx and the UPS trucks can actually be quite problematic. So if you could, in that case, and rather than bring the drones at ground level, bring them to the rooftop where they barely interface with the people on the ground, then there might be more buy-in. It solves the problem with truck flows in bigger cities. And you retrofit rooftops to be more adapted to that type of service. And we're seeing a lot of work being done on that front.
We're actually working with two companies that do exactly that now, Martin. I put them in the box there. Valkyrie, which do a box very much like a postal cluster box, where the drone lands on top and then drops its cargo, and then the box sorts it out into one of 6 parcel boxes and then pings the user to say, hey, come pick up your parcel. And then the other one is IDU, which is a UK-based company, which basically are converting skylights in houses into being a drone port so that the drone could be taken and dropped off. Both great infrastructure plays, neither of them currently covered under regulations to fly, but you see they're getting the future scope in there.
All right. Martin, do you have any other questions, or shall we move on?
Yes, but I got plenty of questions, but if somebody wants to ask another one, that's fine.
Yeah. Ryan.
Yeah, hey, I'm Ryan. I'm with the VFS McGill. And the one question I had is that while hearing you speak, I felt like all the hardware, the software, and the technology is here, but the real problem you're facing is really on the regulation side of things. So I wanted to know from your perspective, how should the regulation evolve to keep up with, the current pace of progress of your work?
Should I start and you finish that one, Martin?
Yeah, go for it.
The Transport Canada have done quite a good job of, they hired a lot of new people to look at this. When the RPAS file started 7 years ago, they only had 2 people looking at it, and they were off the side of their desk. Since then, they've recruited over 34 people to look at these cases and take each one on its own merits and try and build the rules. We saw regulations come out over 2 years ago now on new drone flights. They did put CARS Part 9 into law, so the changes were made there. But rules change so slowly that they can't keep pace with technology. And in some ways, that's not a bad thing. You know, we are talking about drones that fly over cities now, which we do. And we're already looking at drones that are up to 300 kilograms in weight, being able to do delivery from shore to ocean, ocean-going vessels. Now, obviously, if there's not regulations in place, people are going to turn that around and fly it over a city. And now we've got a real risk of undeveloped technology. So as a user in this case, I always push the regulator to go faster. But, you know, as a citizen out here wanting to be safe, I'm pleased they do work at a pace and they get it all done. I would like to see more investment brought into the regulator. I'd like to see a clearer path laid out by the regulator, which says, you know, we are going to address these problems. Once we've got here, we're going to go here, and we're going to go here, and we're going to go here, because that would allow me to reach out to my investors and allow them with confidence to say, if we solve these problems, we're going to be able to move to the next step. So encouraging long-term planning and increased budget is what I'd like to see out of the regulators. Over to you, Martin.
I might just share my screen really quickly. Can you see?
Yes.
Yeah.
So I thought that one was always interesting because it's it may sound like everything is new, but it's part of a pre-plan of steps that Transport Canada put together with a lot of the different pieces of the puzzle that are being considered. And clearly, I suspect with COVID, things have been delayed a bit. But there's there was always the ambition that we would start from some of the trials that Philip was part of and progressively build the pieces of the regulations as experiences is gained. And the other thing also to keep in mind is that that's Canada, but there's so much being done internationally. There's each country has a different approach to it, and progressively people might be all going in a similar direction, but they might see some case studies from a specific country and bring it back home and adjust their regulations based on some of the successes or the lessons learned from different projects that have been put forward in other countries. So, but clearly, yes, it's and maybe the other thing, like if we go back to safety, and it's happened before, and I think in Switzerland, there was a couple of events where there were a couple of incidents with drones. One of them fell in the lake, so there was no damage to anyone, but it still highlighted the fact that there could be incidents and the parachute didn't deploy. So even these events that do not gather a lot of public attention, you need to really take a closer look to make sure that you don't wait until there's a really public incident that could pull you back by a few years if something was leading to a major accident or death. So very critical to look at that. And lastly, I mentioned, I think, that earlier, but what's interesting with healthcare and the use of drones to positively help people is that I think it will facilitate public acceptance, and it's somewhat a bit of a Trojan horse. It's you're using it in a way to enable other uses, but progressively by demonstrating that those cases are effective and working, then you can extrapolate that. Well, if you do it with blood or vaccine, then you could do it with coffees and burritos. So it progressively helps the growth in the knowledge base and to develop strong regulations and cases where private industries could introduce some different concepts beyond the healthcare system.
Thank you for your question, Ryan. Georges?
Thank you for the answers.
Yes, hi. My name is George, and I'm also part of the VFS projects team here in McGill. First of all, I would like to thank you for sharing your experiences. I found them very insightful. I have a question for Mr. Reece that might be a bit too specific, but I would love to hear his opinion on it. For some context, we are currently in the process of designing and fabricating a hexcopter that should be able to carry a payload of about 10 kilograms. You mentioned before, and it was also shown in pictures, that one of the ways of attaching the payload on such a drone is inside a bag slung underneath it. I was curious what led you to this design choice and what are some of its advantages and disadvantages. For example, I would think that such an attachment might cause the inertia of the load to affect the drone's flight, as opposed to it being completely fastened on the drone.
Good question. Now I'm going to speak to a team of engineers about things. I'm going to have to be careful what I say. So a slung load obviously does cause lots of inertia problems. This was a fairly, whilst it was a soft case, it was a fairly rigid soft case. It was tied and connected tight to the base with 2 clips. So there wasn't a whole lot of pendulum effect going on there. It was really selected not for its aerodynamics at all, but so that we could easily detach it and reattach it, and that it had thermal properties, because we were carrying the equivalent to blood, plasma, and platelets, so they had to be kept at a chilled temperature. So that was a thermal bag that you saw there. Because we knew the flight time was going to be reasonably short, we decided to go for a thermal bag with cooling inside of it, rather than with an electrical measures to do refrigeration, which would obviously increase the weight quite a lot. So we have experimented with slung loads like that, which are great for center of gravity, but not so much for the pendulum effect. We've also experimented with loads that are carried inside of the body and then lowered through a pulley system to the ground. They come with a whole host of their own problems, mostly on the delivery at the end, where the person is eager to get it, where you can get snagging from a tree, where you get your pendulum. And it's often at the end of the flight where you've got the least battery power to correct for these kind of things. We've also experimented with a drone that lands and has the cargo where somebody can just open it up. The problem there is crew tend to be pretty harsh with it. You can't afford for it to take off then once its cargo bay has been accessed, because your weight and balance could be off and you really need somebody to do an aircraft inspection. The most success we've had is, and the audience is probably too young to appreciate the Thunderbird sort of thing, where the drone lands and then it detaches its center cargo and then takes off again. So we're always dealing with the same known weight capacities, and we basically just leave a box on the ground. The beauty of that box that we're leaving on the ground is it can now be linked with the drone as well if we want to, so that the drone can report back to the end user or the pilot that the box has been opened, or the box has been discarded, or the item's been taken out. So for in dispatch, for example, we can say it's been delivered. Now you can start giving resuscitation instructions or what have you. So there's lots of different ways, and probably some we haven't thought of yet, but we went for simplest and easiest.
Thank you for that. From what I understand, then it has to do a lot with your objectives and restrictions posed by the payload itself, depending on the situation. And I think that the other members found the answer very helpful too.
Thank you.
All right, so Dusan, do you want to ask a question? I see you raising your hand.
Yeah, sure. Can everybody hear me?
Yep.
Okay, so my question is, a multi-copter configuration was chosen for the delivery. As you said, fixed wing cannot really land in short spaces. But what about headwind and the speed of the multi-copter? Because a multi-copter is the worst aircraft there. Let's be frank with this. A fixed wing has a much better efficiency of flying.
I would challenge you on it being the worst. I think the worst is actually the one we all thought would be in the industry, we thought the best solution would be a hybrid between a fixed wing and a multi-copter, which basically has the advantages of being able to take off and land in a rotary fashion and then transition into lift from fixed wing. On paper, it sounds like the best solution, but so far everybody's seemed to result in it being the worst solution. Wingcopter are probably the ones who are making the best bet out of it. But there's so much energy lost in the transition. You're really getting the worst of both worlds. Bell Flight have got an interesting one where basically it takes off and then transitions by just the drone moving rather than by any moving parts as such. So again, the copter was chosen this instance for simplicity and ease, and already being accepted by Transport Canada as having redundancies built in because it was six motors rather than 4, rather than a quad. So it would it be the ideal solution for short range, less than 10 kilometers? I think a multicopter probably is, because it needs the least infrastructure. Once you start to get over there, you do need lift. You either need lift from your wings, or you need a larger drone that can operate in some other way, carrying more fuel, be it a combination fuel engine or hydrogen or whatever.
Yeah,
Did that answer your question, Dusan? Thank you.
Yeah, sure. Thank you very much. A second question, it's about the speed and headwind. So if you have any kind of headwind, how do you reach your destination?
Mm-hmm. Not so much on this mission because we were flying in a reasonably controlled environment, but we're doing flights now from Lady Minto Hospital to health centers, which are 26 kilometers away over the ocean. And really, we have to get into micro weather predictions. So we equip the pilots with basically a crib sheet for if the wind's blowing in this direction at this speed, we're not going to make it. Then you make your decision. Okay, the headwind looks like it's going to be in our favor, or it's going to be a side wind, which it often is against us. And if our calculations are all right, we will make it. But we need to check that repeatedly along the way, map, watch, ground, to make sure that we are where we think we should be at the consumption of battery power. And if not, we need to have an alternative. So it's really, a lot of it goes into planning the routes and planning alternative routes along the way if micro weather comes up and interrupts us.
Yeah, great. Thank you.
Thank you. So Maya, I see you raising your hand.
Hi, I'm from the Biomedical Engineering Club, so my question is a bit more medical, but we've already, you guys touched on how the drones have been adapted in terms of what is being delivered by talking about how payload is rearranged, which I found very interesting, but I'm wondering, for your project with blood products and for the projects we've been talking about with vaccine rollout, what modifications can be made if temperature has to be controlled or other conditions like that specific to the product?
Well, I'll just start, and Philip will probably add with his most recent projects on this. So for temperature monitoring, you need continuous monitoring, and you need to have it recorded. It has to be the payload has to be protected from the wind. The wind will cool it, which is good in the summer, but will make the product become cooler in the wintertime or colder weather outside. So if your product is very sensitive to temperature, like such as blood products, it's a very difficult and challenging issue. And Mr. Danny Brouard is not here, but he did work with Philip on this and developing how exactly which payload we're going to use and what's going to be inside. And so he developed the inside of the container, which is very important. It was equipped with a probe with some phase-changing material to make sure that the blood products would remain in a targeted range. So that was actually very challenging, and they had to do a lot of tests before our data collection. So I believe, Philip, you even did some tests on your own as well, just for the payload, and then that's it. And they, in the lab at EMA Quebec, they had to actually test the phase-changing material and how they installed it inside the payload. So a lot of micro research projects inside this big umbrella study. So this is a real challenge. I could connect you with Monsieur Brouard if you would like to discuss that more, because it's interesting technology. And we'll see more, I think, on this. Yeah.
I would add to Valerie's comments that the thing we had playing in our favor is the drone covers distances like 25 kilometers in 20 minutes. So we can do cooling or heating over a 20-minute period, as long as we get the right payload and the right conditions when it's going in there. We can do it reasonably inert. We don't have to add too much electrical power or electrical weight to refrigeration or heating, because that would seriously limit us.
Yeah, that's it. And ice packs were definitely not our preferred route because it's heavy. And we're trying to develop a technology that is lightweight as well, because we want the weight to be for blood products, not for the payload and not for the ice cubes, right? So that was the whole discussion. Yeah.
That's really interesting. Thank you.
Thank you. All right, Thibault.
Hi, I'm Thibault. I just have a question about more of the finances part of this. Because you mentioned that the project had many hurdles, as if there's the weather, there's the regulations, and you mentioned that it was very lengthy and complicated to get the data sometimes, and also there's sensitive material to transport. So I wanted to know, how did you finance all of this?
You want to know how we funded the project?
Yes.
Okay, well, I can talk people into doing a lot of things, but in the end, one method was, and it's actually, honestly, it was upfront, but it's you want to be in this project, I expect you to volunteer your time. So my data collectors were not paid. I think what worked is this is innovation. People wanted to be part of the project. It didn't matter if they were paid or not. Not everybody, but let's say some people that were important. And in terms of partner organizations, what happened is everybody had to fund their own part. You're EMA Quebec, you're developing the container, you're funding that part. Okay, you are Urgence Santé, you're providing safety for the project. You will be named as a collaborator. You want to be part of this. Well, you fund the paramedics that will be there on site. You will supply the ambulances and provide safety, or else you're not with our team. We'll find another partner. So it was like that. You want to be part of the team. You want to be in this publication. You want to advance the knowledge on this topic. Well, you have to contribute. So that was one element that I should mention. And then you need actual money to pay for stuff like food, for equipment. You need some funds. And I did knock on the hospital foundation's door. And they've been very helpful over the years. They seem to like innovation. They like, because it's an academic a healthcare center, right? So they're interested in supporting research and developing new technologies. And our project can help trauma, resuscitation, disaster. And this is part of the mission of the Montreal General Hospital, which is a trauma center, level 1 trauma center in our city. So they agreed to fund part of our project. And finally, the other funding partner is Dr. Richard Fleet. He's not on this call, but was a very important person. He also contributed in the other project about the swimmer surveillance. So he is a full-time researcher. He has a PhD in psychology. He's also an emergency physician. But right now, he really is dedicating his career to study the differences between resuscitation and emergency care in rural areas compared to urban areas. He has a number of publications on this. So he thought this project would be interesting because it could provide solutions for more remote areas. So that's where his interest is. And you'll see at the beginning, there was a slide about all the collaborators. Well, one of the slides is Desercom, which is a big company producing ambulances and equipment and everything in Quebec. And they are funding his research organization associated with Université Laval. So we had, so the one thing we did not do, and this was a decision, this was my decision. I decided not to apply through grants because I wanted this project done yesterday. This is a field that is in constant evolution. So if you apply for a grant and get an answer in 6 months and they say no, and then what do? Then the winter comes, you can't fly because it's cold and we're not going to do research under, an ice storm. So I'm not very patient. I'm an emerge doc, right? I like to fix problems right now. So I opted for money right now rather than maybe more money in the future. It's as simple as that. It's a gamble, but it worked. And I don't think I would necessarily do all my projects this way, but for this one, I believe it was the right thing to do. And then the pandemic hit. We would never have finished this project. So I'm really thankful for that decision. Sorry, that was a long answer. We passed the time. It's 7:30 now. I feel like we can continue on for a long time.
Indeed, we did. It was a very, very interesting panel. I'd like to thank you, Dr. Valerie Homier, Mr. Martin Leprohon, and Mr. Philip Reece for your time. I believe everyone enjoyed this this panel, and we really hope to work with you soon again.
Yeah, so find ideas and believe in your ideas. You can see what Philip Reece has done. You can see what Martin is doing in aviation. Like they were sitting where you were many years ago. And so if you keep working at what you're passionate about, you can push boundaries further away, and we need you to do that. So we're open to hearing all your ideas, and it would be a great idea to collaborate, I think, in the future.
Awesome. All right. So this is the end of this panel, and thank you all for coming.
Thank you.
Have a good night, everyone.
Thank you very much.
Thanks, Martin.
Merci beaucoup. À la prochaine.
Bye.
Okay, bye.
Thank you.
Thank you.